Biology with Dr. E.
Next, we discuss lipids. Like carbohydrates, lipids also contain carbon, hydrogen, and oxygen, although in lesser amounts. Phosphorus can also be found in more complex lipids. Lipids are insoluble in water, but dissolve in other lipids and in organic solvents such as alcohol. Lipids include triglycerides, phospholipids, steroids, and eicosanoids. Let's review triglycerides. Triglycerides are commonly known as fats when they are solid or oils when they are liquid. A triglyceride is composed of two building blocks, namely fatty acid and glycerol. The fatty acid and glycerol are in a ratio of 3 fatty acids to 1 glycerol molecule. Fatty acids are linear chains of carbon and hydrogen, also called hydrocarbons, with a carboxylic acid group at the end. Glycerol is a modified simple sugar, also called a sugar alcohol. Triglycerides play a role in energy storage. They are found under the skin where they insulate deeper body tissues from heat loss and protect them from mechanical trauma. Figure A here illustrates one of 3 dehydration synthesis reactions in the synthesis of a triglyceride. As already mentioned, a triglyceride has 2 building blocks, 1 glycerol molecule and 3 fatty acid molecules. Glycerol is a modified simple sugar of hydrogen, carbon, and oxygen. The fatty acid chains are linear hydrocarbon chains with an organic acid group attached at one end. There are 2 more dehydration synthesis reactions like the one shown here, which should yield a total of 3 molecules of water and 1 triglyceride molecule. Figure B here shows 1 triglyceride molecule consisting of a glycerol and 3 fatty acids bound together by dehydration synthesis. Figure C is a simplified drawing of a simple triglyceride. Triglycerides can be made from either saturated or unsaturated fatty acids. In saturated fatty acids, all carbon atoms are linked by single covalent bonds, resulting in a molecule with the maximum number of hydrogen atoms it can hold. That means there are no carbon-carbon double bonds in the fatty acid. Because of this, the molecules are closely packed together, forming solids at room temperature, for example, in butter. In unsaturated fatty acids, 1 or more carbons are linked by double bonds, resulting in reduced hydrogen atoms. The double bonds cause a kink in the fatty acid, so they cannot pack together closely. This results in unsaturated fatty acids being liquids at room temperature. For example, plant oils such as olive oil. Let's review the structure of phospholipids. Phospholipids are modified triglycerides. They are made up of a glycerol and 2 fatty acids, plus a phosphorus-containing group. The head and tail regions of phospholipids have different properties. The heads are polar and hydrophilic or attracted to water. The polar head group consists of a nitrogen-containing group, phosphate, and glycerol. The tails are nonpolar and hydrophobic or water-hating. The tails consist of fatty acids. Please notice that the fatty acid tail on the left is straight, while the fatty acid tail on the right is kinked. Schematically, hydrophilic heads are shown as round circles, and 2 slender nonpolar tails are attached to the polar head. One tail is fairly straight while the other tail to the right is kinked. Phospholipids are important in cell membrane structure. They make up the bulk of the lipid bilayer. In a watery environment, phospholipids automatically line up with their heads facing the water on either side and their tails hiding away from the water. Next, we look at steroids. Steroids consist of 4 interlocking ring structures. Different steroids have different groups attached to the 4-ring backbone. Cholesterol is the most important steroid. It is made by the liver and also found in animal products such as cheese, eggs, and meat. Cholesterol is a starting material for synthesis of vitamin D, steroid hormones, and bile salts. It is also important in plasma membrane structure.